came to my attention today while I was working on some other stuff that there's no audio on this video that I had uploaded for page 5 of the second review packet. So I'm going to redo that video with the audio, and then I'll continue on to page 6 and beyond. We'll see how many I can get done tonight. So number 21 is at the top of page 5. It says in 2004, school lunch at Rockwell High School was $2.20. In 2009, the cost increased to $3.25. Find the annual rate of change, which is a fancy way of saying the slope, in the price for school lunch from 2004 to 2009. So again, this is a slope problem because of what I circled there. Rate of change is a fancy way of saying slope. So we have 2 points. We have the point 2004, $2.20, and we have the point 2009, $3.25. And we are supposed to find the slope using the slope equation, which is located on your reference sheet. So we simply need to look at these points and realize that one of those points is your x1 and your y1, and the other point is your x2 and your y2. So the slope would be y2 minus y1 over x2 minus x1, which would be 3.25 minus 2.20 divided by 2009 minus 2004. That would be $1.05 divided by 5, which would be 21 cents per year. So our answer would be B, 21 cents per year. Number 22 is also a rate of change problem, a slope problem. It says find the slope of the belt as a positive number. Now remember, there's a lot of ways to represent slope. In this case, we want to represent slope as rise over run. And the diagram, by the way, I spelled rise wrong on purpose so that you would know that the y value always goes on top. Now, in terms of this diagram, they've already told you the change in y and the change in x. The rise, or change in y, is 8, and the run is 20. So all we have to do is plug those values in. 8 feet over 20 feet. And reduce that fraction. They're both divisible by 4, so we divide the top and the bottom by 4, and we get 2 fifths for our slope. So we would say C, 2 fifths. Number 23 is even more of a basic slope problem. So again, this is just practice where we're using our slope formula. That slope formula is found on your reference sheet. You don't need to have it memorized, you just need to know how to use it. So your first point is your x1 and your y1. Your second point is your x2 and your y2. We've probably done 1,000 of these since we were in Algebra 1. All we're doing is plugging in and reducing. So that'd be 4 minus 1 over negative 2 minus 2, or 5 over negative 4 on number 23. And on number 24, x1, y1, x2, y2, this one actually gives us a little bit of a challenge in remembering, because when we plug in our numbers, we have 5 minus negative 5 over 3 minus 3, which would be 10 divided by 0. But we can't divide by 0. If the 0 were on top, that's no problem. We just get an answer of 0, but we're not allowed to divide by 0. So what happens here is that we say slope is undefined because we don't know how to divide by 0. That particular approach is undefined. All right. Find the X and Y-intercepts is the next 2 problems, 25 and 26. Essentially, this is the same thing you did when you graphed lines. It's cover-up method. So for the X-intercept, that would be the point where, that is where y is equal to 0. So you would take the equation and replace the y with 0, which essentially makes that entire term drop out, leaving 2x equals 6. We divide by 2, And we get that when y equals 0, x equals 3. That means the point 3, 0 is the x-intercept. We do the exact same thing for the y-intercept with one minor change, and that is the y-intercept is where x is 0. So instead of plugging in a 0 for the y, we plug in a 0 for the x, which gives us negative 3y equals 6. We divide by negative 3 on each side, and we get that when x equals 0, y equals negative 2, meaning the point 0, negative 2 is the y-intercept. Try to circle that again so it doesn't screw up the next problem. There we go. Okay, 26 is the same problem. So again, for the x-intercept, that is where y equals 0. So we plug in a 0 for y, which makes the y term drop out. 1/4 x equals 3 means we're supposed to be multiplying each side of that equation by 4, which would cancel the fraction and give us that x equals 12 when y equals 0, which means the point 12, 0 would be the x-intercept. And again, for the y-intercept is where x equals 0. So we plug in a 0 for x, which means the x term will drop out, leaving negative 2y equals 3. Divide by negative 2, and y would equal negative 3/2. So the y-intercept would be the point 0, negative 3/2. All right, 27 is a word problem. It says Peter has $20 when he arrives at the bowling alley. He rents shoes for $3 and each game costs $3.75. The function y equals 17 minus 3.75x represents the amount of money y he had remaining after bowling x games. It then asks you to find the 0 and explain what it means in the context of the situation. Now that word 0, remember that they could have just as easily said solution, they could have just as easily said root, they could have just as easily said x-intercept. They all mean the same thing. What they're telling you to do is let y equal 0 and solve for x. That's what you're supposed to be doing in these two word problems, 27 and 28. So we put a 0 in for y, which would give us 0 equals 17 minus 3.75x, and we solve for x. So we would subtract 17 from each side, which would give us negative 17 equals negative 3.75x, and then we divide by negative 3.75, and we get x is 4.53 repeating. So there's the x value. That is the root solution 0 x-intercept. Now we just have to write what that tells us. Well, again, x is representing the number of bowling games he has played. So here's the thing. You can't play 0.53 repeating bowling games. So what we would say here, the context of the situation is telling us that Peter can play 4 games, but cannot afford a 5th. Because he doesn't have enough money. He only has enough money to buy 0.53 repeating of a game. So that would be what we're looking for in terms of the context of the answer, of the solution. What does it mean in the situation? Let's do another one. This is the last problem on the page, so this will be the last one on the video. Trudy bought a $20 prepaid long-distance phone card. For every minute that she talks, 25 cents is deducted from her card. The function f of m equals 20 minus 0.25 m represents the amount of money f of m she has left after talking m minutes. Find the zero, there's that word again, and explain what it means in the context of the situation. So we are going to let f of m equal 0, and we're going to solve for x. So 0 equals 20 minus 0.25 m. We're going to subtract 20 from each side, which gives us negative 20 equals negative 0.25 m. And then we're going to divide by negative 0.25, which would give us 80 for m. So the root solution 0 x-intercept is the value when the function is equal to 0. So that'd be 80 minutes. Now we just need to explain in the context of the situation what that means. Well, m is the number of minutes she has talked. So what this tells us is that Trudy can talk for 80 minutes before her phone card runs out. Because she can afford 80 minutes of talk time on her $20 phone card. That's it for page 5. Hopefully this video has audio and I don't have to do that again.